a segment of a circle. There's an area formula associated with this as well. Okay. When you're looking at a segment is it's a simple figure. It's the region that's cut off by a chord in the arc of the circle that's intersected by that chord. But the area formula for it is a little more complex because it's a combination. You actually have to identify the sector that's enclosed by this whole region. So here you would look at this entire sector. And then what you're going to do is you're going to remove a portion of that sector. And the portion that you're going to remove is going to be this triangle. Once you remove that triangular portion from the sector, you're left with the remaining segment. Okay? And so it's that idea of removing that derives the area formula for a segment. Okay, so we're going to take the area of a whole sector, so m over 360 times pi r squared, and we're going to remove the triangular region from that, and that's going to leave us with the actual segment of a circle. Right, and so even though we haven't talked about triangles yet, the area formula is very familiar to everybody, 1/2 base times height. And so this shouldn't be a huge stretch to do this calculation. And now, as far as the base times the height, okay, for most cases, the base is going to be the length of the chord, and the height is going to be the distance from that chord to the center. Okay, but this is not always going to be the case. Okay? It's in one specific circumstance. Okay? There's an easier way to approach it than using the chord length as the base and the height as the distance from the chord to the center. And that is if your central angle measure is 90 degrees. And the reason for that is if you're looking at a 90-degree angle here, rather than using this as the base and this as the corresponding height, okay, the height of a triangle is just the perpendicular distance from a vertex to the opposite base. Well, since the two radii of this circle are already intersecting at a perpendicular, those can be your base and height. Okay? So if you're dealing with a 90-degree angle, your base and your height, instead of being the chord length and the distance from the center, are just going to be the radii. And so if you get any problems involving the area of a segment of a circle, in like right now, it'll be either this 90-degree angle here, or I'll give you the information about what the base length and the height or distance from the center is. And once we complete Chapter 5 or get into Chapter 5, you guys will be asked to do more of these types of calculations from scratch, because you'll have ways to approach it using trig and Pythagorean theorem. Okay, but for right now, you'll be given that information. Okay, so let's take a look at this example 4. We'll go through it together here. If you want the area of a segment whose radius is 10 centimeters, so if we use this diagram provided, here's our radii of 10, and we're using a 90-degree angle. So if the central angle is 90 degrees, that means our intercepted arc or arc measure also going to be 90 degrees. And so it's just a matter of plugging this into the correct formula. M over 360 times pi r squared minus the triangle 1/2 base times height, and fill in the values. So our arc measure is 90 degrees. The radius was given as 10. And here's the special case. We're dealing with a right triangle to remove. So the base and the height can simply be the radii. So 10 and 10. And so if we use this as our calculation, we can now simplify. The factors of 10 cancel. 9 goes into 36 4 times. 10 squared gives us 100 pi over 4, minus 2 goes into 10 5 times, so 50. And you can continue to simplify. 4 goes into 100 25 times, so 25 pi minus 50 is your solution. And again, you would label the units centimeters squared because it's a two-dimensional area, but that would be your exact answer, right, written in terms of leaving pi in the answer. Okay, again, you'll see more of these in Chapter 5 than you will in Chapter 4.